Okay, so now we will discuss about the what are the important terminologies. Okay, now before starting with the machine, now we have to know what are the terminologies that we have to know. That means first terminology is what is load. Now load, it is actually, it is the resistive force. The definition is, it is the resistive force that we have to overcome by machine. So what is load? Load, it is actually a resistive force that we have to overcome by machine. Okay. Now what is effort? Effort, it is the applied force on the machine to overcome the load. It is the applied force on the machine to overcome the load. Now what is, now we'll discuss. Okay, suppose let's take the example of crowbar only. That means this is the crowbar, so this is the load. Load means this is the load. That means this is the resistive force. This is the load. This is the load is the resistive force that we have to overcome. That means this is the load. This is the load, and this is the effort. Effort means the force that we are applying on the machine. So this crowbar, it is a machine. Okay. So the effort means the force that we are giving on the machine to overcome the load. Okay. And load, it is a resistive force to be overcome by the machine. Okay. So this is the two things that we have to know. That means the first and the most preliminary thing of the machine is the load and the effort. Okay. So the force that we are giving, it is the effort, and the force that we are overcome by the machine, that is called the load. Okay. So effort means the force that we are applying, and load, it is the force, that is the resistive force that we have to overcome by the machine. And what is mechanical advantage? Mechanical advantage is nothing but the ratio. It is the ratio of load and effort. It is the ratio of load and effort. Okay. So this mechanical advantage will define. That means suppose for a machine, the value of the mathematical advantage will determine which type of machine it is. Okay. Let's say, now see, suppose in case of crowbar, we were putting less effort and the load was very high. Load, that means load means the weight of the stone. The weight of the stone for crowbar, that means the weight of the stone is very high and the effort that we are giving is very less. So here you can see. Here you can see load is greater than effort. In case of crowbar, or you can say in case of jack screw. In case of jack screw, actually with the help of jack screw, we'll lift the car. This car, it has a very huge weight. This load is very high, and the effort that we are putting is very low. So load is greater than effort, obviously. So if load is greater than effort, if I bring this effort at the denominator part, then what will happen? This is greater than 1. So I can say the mechanical advantage is greater than 1. Now these machines, that means jack screw, crowbar, spade, so these are the examples. These are the machines that I have gave in the example of force multiplier. So if the mechanical advantage, if any machine the mechanical advantage is greater than 1, that means it will act as a force multiplier. It will act as a force multiplier. Now, if load is less than effort, now the interesting, there are some machine where we have to give more effort than the load. Some machines are there where we have to give more effort than load. Then what is the use of these such machines? I will give some example. Scissor, knife. These are the example of machines where we have to give more effort, but the load is very low. That is lower than the effort. Suppose, in case of scissor, we used to cut clothes, or you can say we have to cut the pages. Now see, in those machines, what you have to do? You have to give more effort to cut the page. The weight of the page is very low. The weight of the page, the load of the page is very low. Okay, but you have to give the effort to cut the load, to cut the page. Okay, so in those cases, so this, if load is less than effort, then what will happen? Load by effort is less than 1. That means it implies mechanical advantage is less than 1. Mechanical advantage is less than 1. Okay, load by effort, that means the mechanical advantage is less than 1. Then this type of machines will helps to velocity multiplier, or you can say it helps in gain in speed. So the machines which have mechanical advantage less than 1, those machines will help to gain the speed. Very important thing. That means those machines, that means like scissor, like knife, we can we can cut the pages, or we can cut the cloth very fast with the help of those machines. But those machines we have to give more effort, okay, than the load. Okay, so this is the significance of mechanical advantage less than 1. So the machines which have mechanical advantage less than 1, they help in gaining in speed. Now, there are some machines where load is equals to effort. Some machines are there where the load is actually equals to effort. Now, in these cases, load by effort is equals to 1. That means mechanical advantage equals to 1. Mechanical advantage is equals to 1. Then, now see, load is equals to effort, that means mechanical advantage is equals to 1. Then what is the need of these things? Now, this is actually happens in case of pulley. What is the significance of pulley? Now, the machines which have mechanical advantage equals to 1, they actually change the direction of the effort. The pulley is used to change the direction of the effort in a convenient direction, or in the desired direction, the direction where we want to give the effort. So these machines, though its mechanical advantage is 1, that means we cannot gain something, that means we cannot gain the effort, or we cannot gain the effort, that means we cannot that means these machines will not do force multiplier, these machines will not gain the velocity. So these machines will help to change the direction of the effort in the desired direction. So these are the three things. That means if mechanical advantage is greater than 1, then it will act as force multiplier. If mechanical advantage is less than 1, that means it is a gain in speed. And if the mechanical advantage equals to 1, then it will act as a pulley. These three things we have to read. That is, if mechanical advantage means it is the ratio of effort load by effort. Now mechanical advantage, the value of the mechanical advantage will determine the which type of performance or which type of work the machine will do. Okay, the functions of machine. If mechanical advantage is greater than 1, then those machines will act as a force multiplier. Then the function of the machines will be to gain the effort. Okay. Now, in case of mechanical advantage less than 1, those machines will not act as a force multiplier. They will gain the speed. They will helps to gain the speed of the work. Now, the machines which have mechanical advantage less equal to 1, they will neither act as a force multiplier, they will nor gain in speed. What they will do, they will change the direction of the effort in the desired direction. So this is the main fundamental thing of mechanical advantage. Okay. Now we will do velocity ratio. Now what is velocity ratio? The velocity ratio is again the ratio of velocity of effort by velocity of load. It is actually the velocity of the effort by velocity of the load. Okay. Now we will see that this velocity of the effort by velocity of the load, that means now if velocity of that means if the velocity of the load, that means velocity of the effort is greater than velocity of the load, that means this is the velocity of the effort by velocity of the load is greater than 1. That means VR is greater than 1. So again, this velocity ratio also determine which type of function the machine will do. Okay. Now if velocity of the effort is greater than velocity of the load, that means the velocity of the effort is greater than velocity of the load, that means VR is greater than 1. Then what will happen? This will act as a force multiplier. This will act as a force multiplier. Okay, so for velocity ratio, it is greater than 1, it will act as a velocity multiplier. Now, you can see the example of jack screw. In case of jack screw, what we will do? This jack screw so we put the effort here and the car is lifted, that means the car is lifted. Now what will happen? The effort, the displacement of the effort, the velocity of the effort is greater. The velocity of the effort is greater, and the velocity of the velocity with which the car is moving upward is very slow. The velocity with which, in this case, velocity with which car is moving up is less than the velocity of the handle of the jack. So the velocity with which the car is moving up is very less than the velocity of the handle of the jack screw. Okay, so the handle of the jack screw is moving, that means the effort is moving, that means the velocity of the effort point, is greater than the velocity of the load point. Okay, so here in this case what we can see, velocity of the effort is greater than the velocity of the load. In this case, the velocity of the effort is greater than the velocity of the load, that means the velocity with which the car is moving up is very less than the velocity of the handle of the jack screw. So here actually velocity ratio is greater than 1, and we know the jack screw, it is used as force multiplier. So for the machines which have velocity ratio greater than 1, they are used as force multiplier. Very important. Now, if velocity ratio is less than 1, that means velocity of the load, velocity of the effort by velocity of the load is less than 1. That means velocity of the effort is less than velocity of the load. That means the velocity of the load is very large than the velocity of the effort. Now take the example of scissor. Now see, if this is the page, now this is the effort point and this is the load point. Now you will see, if I move the scissor like this is the distance of the effort that is moving, and this is the distance of the load that is cut. That means since the blade of the scissor is bigger, so it can cut a long distance. As the blade of the scissor is longer, it will cut the longer distance. That means in the scissor, the velocity of the load, that means the velocity means how much distance it is cutting with respect to time. Okay. So in the scissor, in case of scissors, the velocity of the load is greater. Here actually velocity of the load is greater than velocity of the effort. So I can say, so in this case the velocity ratio is less than 1. So for velocity ratio less than 1, they will act as to gain the speed. So the machine which have velocity ratio less than 1, that means in case of scissor, if you say in case of knife also, the blade of the knife is longer. Okay, that means that is why the speed with which it cut the pages is greater. Okay, but here we have to give more effort than the load. Here actually in the velocity ratio less than 1, we have to give more effort than the load. Okay. So this we have to maintain. That means the velocity, if the velocity ratio is less than 1, that means we have to, that means they will act as a gain in speed. Okay, less than 1 means they will act as a gain in speed. Now if velocity ratio is equals to 1, that means in case of pulley, this is the effort point and this is the load point. The load, that means the velocity. Now see, as the string is moving downward, the bucket will move upward. So as the effort point is moving downward, the velocity with which the effort point is moving downward, the velocity with which the effort point is moving downward, with the same velocity the load will move upward. Okay, so here actually velocity of the effort is equals to velocity of the load. In case of pulley, the velocity of the effort is equals to velocity of the load, and this will, and this, if the velocity ratio is equals to 1, this will act as change in direction of effort in the desired direction. In the desired direction. Velocity ratio, if the velocity ratio is equals to 1, that means velocity of the effort is equals to velocity of the load. That means this velocity ratio will help him change the direction of the effort in the desired direction. Okay, so this is the use for it. So velocity ratio also determine which type, which type of machine will work, that is which type of function the machine will do. Okay, so let's recap. Mechanical advantage greater than 1, mechanical advantage less than 1, mechanical advantage equals to 1. Again, velocity ratio greater than 1, velocity ratio less than 1, velocity ratio equals to 1. If mechanical advantage greater than 1, that means it will act as a force multiplier. Mechanical advantage less than 1, that means it will help in gain in speed. If mechanical advantage equals to 1, that means change the direction of effort. Now if velocity ratio greater than 1, that means this will also help, that means this will also act as a force multiplier. If velocity ratio less than 1, that means this also will act as a gain in speed. If velocity ratio equal to 1, that means this also helps in change the direction of effort. So this is the mechanical advantage and this is the velocity ratio. Okay, so this is the synopsis of mechanical advantage and velocity ratio. Now the important thing is that mechanical advantage and velocity ratio, since mechanical advantage and velocity ratio, they are the ratio of same thing. That means mechanical advantage means load by effort That means load is also a force, effort is also a force. That means they are having same unit. Force means it's a physical quantity, and we know that for physical quantity, for force, the unit is Newton. Okay, so load is also a force, that is Newton. Effort is also a force, that is Newton. Cut, and so it is unitless. Velocity ratio, it is also velocity of the effort by velocity of the load. That means same unit. That means meter per second by meter per second. That means it is also a unitless. So important thing is that mechanical advantage and velocity ratio both are unitless quantity. I think it is clear. Now the next terminology that we have to know. Efficiency. What is efficiency? Efficiency, it is actually work input by work output. Sorry. Work output by work input. So efficiency means work output by work input. This is the ratio. Efficiency, it is the ratio of work output and work input. Now work output means, what is work output? That means it is work done by the machine. This is the work done by the machine to overcome the load. And what is work input? It is work done on the machine to work done on the machine by the effort. Work done on the machine by the effort. So the effort, now here actually work input means effort is doing the work. Effort is doing the work, that means we are doing the work, and work output means machine is doing the work to overcome the load. Okay? Now we know that what is the formula of work done? Work done, the formula is force into displacement. We have already learned in the second chapter, that is what is work done. Work done equal to yes. Work done means force into displacement. Yes. So force means, now if it is work, if it is work input, work input means effort is doing the work, that means force in place of force, that is effort into, it is effort into displacement of effort point. And if it is work output, then this, that is machine is doing the work to overcome the load, that is load is overcome, that is load is a force. So load in place of force, you have to put load. load into displacement of the load point. Displacement of the load point. So work input is the effort into displacement of the effort point. Work output means load into displacement of the load point. I think it is clear. So I can write work output means load into displacement of the load point, and work input means effort into displacement of the effort point. I think it is clear up to this. The efficiency, it is denoted by eta. It is eta. How you have to write eta? Just write simple n and just extend this hand. Okay, this is eta. Okay, so this actually load into displacement of the load by effort into displacement of the effort. Now load by effort into, now displacement of the load means displacement of the load. If I divide both sides by t, I can do this. Divide that means numerator divided by t, that is time, and denominator divided by t, that is time. Now we know that displacement by time, this is actually velocity. Now what we can write, load into effort, load by effort into the displacement of the load point by time. That means it is actually the velocity of the load by displacement of the effort point by time. That means velocity of the effort. That means, now see, load by effort, the ratio of load by effort, it is divided by mechanical advantage and I can write this, that is reciprocal. I can do the reciprocal, that is 1 by v, velocity of the effort by velocity of the load. Now see, mechanical advantage into 1 by, what is the ratio of velocity of the effort by velocity of the load? It is actually the velocity ratio. So we can write efficiency eta is equals to mechanical advantage by velocity ratio. Therefore I can write mechanical advantage is equals to eta efficiency into velocity ratio. This is the relation between mechanical advantage, efficiency and velocity ratio. The simple derivation that we have to know. This is very important, and this type of question will come in the exam. That means what is the question will become, that means what is the relation, establish the relationship between mechanical advantage, efficiency and velocity ratio. And numerical based question also comes. Like this, it will be say that suppose for machine the velocity ratio, mechanical advantage is 0.5 and the velocity ratio is 0.75. Then what is the efficiency of the machine? Just you have to utilize this expression, this formula, and find out what is the efficiency. Okay, efficiency means mechanical advantage by velocity ratio. Okay, so this is the derivation of efficiency, the derivation of mechanical advantage, velocity ratio and the efficiency. Again, efficiency, it is also the ratio of the two similar quantities, that means work done output by work done input, and we know that the unit of work done is joule. We know that the unit of work done is joule. Then work done output, it is also in joule. Work done input, it is also a joule. So I can say for efficiency, it is also a unitless quantity. Unitless. Efficiency is also a unitless quantity. Now, some important point we have to understand. So up to this, I think everyone it is clear. If anyone having any doubt, then you can ask me in the class. Now, efficiency, it is work output by work input. Now see, the work, that means how much energy we are giving on the machine and how much output energy we are getting. Okay, that is the efficiency. How much work we are doing and how much output we are getting. Okay. Now, there is no machine in the universe. There is no machine in the universe which give. That means, suppose we are giving. Suppose this is a machine. Let's take it to the machine. We are giving 10 joule work. No machine in the universe which give exactly 10 joule work output. That means the energy which I am giving, it will not give exactly that amount of energy as output. Some energy loss will be there by the machine, and after losing some energy, it will give, suppose it says it is giving 8 joule output. So the amount of energy that we are putting, that we are giving to the that means work done means energy. So the amount of work that we are doing, the machine will not exactly transfer that amount of work in the output. There will be some loss. Okay, there will be some loss. And actually, there are some reasons are there which will cause this loss of energy. Okay, so in case of ideal machine means exactly the ideal thing. That is, in case of ideal machine, there only the work output, that means that work input it is exactly equals to work output. So for ideal machine only, the amount of work that we are providing on the machine, that the amount of work done will be done by the machine to overcome the load. That means work input is equals to work output. This will happen in case of ideal machine. Now in our universe there is no such ideal machine exist. Our engineers, they always try to make ideal machine, but still now they cannot make the ideal machine. Obviously some kind of energy will be lost and work output will be always less than the work input. So for practical machines, work output should always less than work input. Now the question may arise in your mind, that means in the machine which act as a force multiplier, the machines which act as a force multiplier, they actually multiply the force. That means suppose we are giving less amount of effort, but the car, that is a huge load it is lifting, then how there actually the less amount of work is done. Now the very important point you have to notice, that means in case of force multiplier, let's say in case of jack screw only, the velocity, that means the displacement of the load is very less. Velocity of the load is very less, but the velocity of the effort is very high. That means we have to put the less effort, but the velocity is very high. That means here the displacement of the effort and here the displacement of the load. Now in this jack screw, though the load is greater than the effort, but the velocity of the load, that means the displacement of the load, is less than the displacement of the effort. Now you will see, if you multiply this one, that is load into displacement of the load, and this is effort into displacement of the effort, you will see this product is always less than. That means work done by the load is always less than work done by the effort. That means this is actually the work input and this is actually the work output. Okay. So in the machines which will act as a velocity which will act as a force multiplier also, there also the efficiency is always less than 1. That means if work output is less than work input, that means work output by work input is less than 1. That means efficiency always less than 1. So for ideal machine, for practical machine, that is in a practical universe, efficiency of any machine should be less than 1. Okay. So in case of velocity in case of force multiplier also, there also the efficiency is less than 1. Now in the book there are 3 reasons given why the energy loss is taking place. Now machine actually lost these energies. The energy that we are giving, some amount of energy is lost and rest is giving as the output. So where the energy is losing? Now there are reasons are there in the book. 3 reasons are given for this energy loss. First one is the moving part of the machine is not weightless or frictionless. Moving part of the machine is not weightless or frictionless. That means, suppose talking about jack screw only. Let's talking about jack screw only. Okay? Now this handle is moving and this platform is also moving. Now when we are putting the effort, there is some weight of the handle also. So this weight of the handle will lose some energy. That means the energy that we are putting on the machine is lost due to this weight of the handle or due to this platform also. This platform is also moving. So some energy is lost to overcome this weight of the handle also. So this weight of the handle cause some energy loss. That means input energy is lost by this weight of the handle also. And again, there is some friction when it is moving. There is some friction here. Some friction is happening here. This friction, due to this friction also, the energy is lost. And the very convenient, that is a very useful example is after a long time. That is, suppose you are driving the car. After long time driving the car, the car engine is getting heated. Why? Because of this friction. Because of this friction of the machine, that is because of the friction, this heat energy develops, and we know that the heat energy will, that is due with the help of this heat energy, the energy is loose. Okay. So friction will cause heat energy and the energy will lose. That means the amount of energy that we are inputting, some energy will lose due to the weight of the moving part of the machine and due to the friction. Second one is strings are not perfectly elastic. In case of pulley, we use string. Now, in case of pulley, since the string that we use in case of pulley, they are not elastic. Now, elasticity, the property, you will study in class 11. So, this point maybe some of you cannot understand this point, okay, because the elasticity we will discuss in class 11. Okay, so as the string is not perfectly elastic, some energy is lost due to this string also. This string will cause energy loss. Okay, string will cause energy loss. Again, third point is some part of the machine is not perfectly rigid. Now we know that if the body is not rigid, then obviously it will change its shape. Okay, so the effort means the force we are giving. Okay, the force we are giving. Now if we are applying the force and if the part of the machine is not perfectly rigid, then it will change the shape. Obviously it will change the shape, and if the force is utilizing to change the shape of the machine part only, then obviously some energy will lose due to this non-rigidity of the machine. I think it is clear. That means since the part of the machine is not perfectly rigid, then also some energy is lost due to the changing shape of the machine parts. Okay, so these are the 3 points that you have to understand, that by these 3 points only, by these 3 ways only, the energy is lost. Okay, so first one is, as the moving part of the machine is not weightless and the friction they are also not frictionless, so due to the friction and due to this weight of the machine, some energy is lost. The amount of energy that we are inputting, some energy is lost due to this. Second point is, the string is not perfectly elastic, and due to this non-elasticity also, the energy is lost. And some part of the machine is not perfectly rigid. That means since the part is not rigid, obviously it will change the shape of the machine, and if the change of the if the machine part it change its shape, then obviously the energy is lost. That is, some energy will lost due to this deformation of the machine parts, and obviously the machine will become less efficient. If the machine, if suppose in case of crowbar, you want to lift a heavy stone. Right? Suppose you are putting the effort, and what will happen? The crowbar will bend its shape. What will happen? First of all, the efficiency of this crowbar will decrease, and less amount of displacement will happen. The force, that is the effort that we are giving, the less amount of work it will done. Okay, that is why the input, that means the energy is lost due to this deformation. I think it is clear now. Okay, so this is all about this is up to now. The next video will be on the lever. Okay, so I think up to this it is clear to all of you.